Hello, my name is Violet Penman, and I am a student intern here at the UWRF Office of Sustainability. And today we'll be bringing you on a virtual tour of the central heating plant here on campus. So, the mission of the central heating plant is to provide uninterrupted steam service safely and economically. So, what that kind of means is that water is heated through a fuel source, usually in this case, natural gas, sometimes fuel oil. And that heated water produces steam, and that steam is then funneled throughout campus through pipes to heat areas of campus as well as heat the hot water on campus. And the heating plant supplies steam that's utilized not only for hot water and heating, but also sterilizers, humidifiers, distillers, that sort of thing. So it's really an important part of campus and keeps campus running. A couple of quick facts here. The central heating plant was built in 1964, so it is pretty old at this point, but it has had several renovations, additions, different equipment being brought in to make sure that it's as efficient as possible. The current value of the campus heating plant is $14 million, so that's a pretty big asset for campus. The speed of the steam going through the pipes, and again, to give a little background, the steam is being produced all of the steam is being produced in the central heating plant, and then it's shot through tubes and funneled out to different areas of campus. So when it's leaving the central heating plant, the steam is going at a speed of about 90 miles per hour, and that will change a little bit depending on the season and other factors as well, but that's about an average. And the average total fuel cost in 2020 was $537,000, $537,794. So that's a pretty big cost, but the asset to campus is also great as well. The UWF heating plant is essentially, to kind of break it down for you, a huge industrial boiler. And so, understanding how a boiler works is important in understanding how the heating plant on campus works. So, put simply, a boiler burns fuel, in this case, probably natural gas, occasionally fuel oil, and burning this fuel creates heat. This heat is then used to boil water. It's very similar to if you were boiling a pot of water to make ramen or something. And this creates steam that is transferred throughout an area as warmth. As the steam cools, it condenses and travels back to the boiler to be used again. So, a demonstration of this is a radiator in a house. A lot of you have probably been in old houses that have radiators. So, the boiler heats the water, and this water is then transferred to the radiator, which helps heat a house. This same concept applies to the campus heating plant, except obviously on a larger scale, and steam is produced instead of water. So, there is a difference there, but it's a good analogy. So this diagram here helps explain the boiler system a little bit, well, the whole system, not just the boiler. And so we'll be kind of going step by step to help you understand it. And our first step here is the water pretreatment. So raw water is used in the boiler system, but you can't just use raw water. It needs to be pre-treated. And although it seems somewhat trivial, treating this raw water before it's used in the boiler is extremely important because water that is too hard, too acidic, or full of particulate matter will create buildup called scale in the pipes, which makes it harder to heat water, which of course wastes energy. So to ensure that the water is heated to the best of the plant's abilities, several techniques and chemicals are used. A lot of these pictures here show these techniques. So water softeners are used to prevent buildup from hard water in the system, while carbon filters remove chlorine and fluorine. The reverse osmosis system reduces the particulate matter in the raw water. Polymer is used to prevent the buildup of scale on pipes, and sodium sulfite is used as an oxygen scavenger to remove excess oxygen in the condensate, which is important because excess oxygen leads to rust. As we all know, if you leave something metal outside, the exposure to oxygen as well as any sort of water, which we obviously have in this case, will lead to rust. Lastly, amine controls water pH, which is optimal at an alkaline 8.5, as acidic water can obviously corrode the pipes. So here's an example of what scale, which I was mentioning earlier, looks like, um, and also a great example of proper water treatment versus treated water. As you can see in the photo, the sample on the left has a large amount of buildup on the inside of the pipe. This makes it so that more energy is needed to heat the water, which is ultimately not very energy efficient. These samples are from 2004, and new technologies such as those in the previous slides have made a huge contribution in treating water correctly to ensure that pipes stay looking more like the example on the right and making sure the plant is more energy efficient. So now we go on to the deaerator, which removes excess oxygen and preheats the condensate. So both pre-treated, aka the makeup water that you can see in the diagram over here, and the recovered condensed water condensate, which is also called the return water. We'll discuss that little bit later. They're both pumped to the deaerator, which removes any additional oxygen from the return water to prevent any chance of rust within the pipes. It also acts as a preheater for the water making its way to the boiler, aka the feed water, and it heats this feed water to approximately 200 degrees Fahrenheit. So after this water is treated, it goes to the boiler, which is the heart of the operation. The boiler is this mint-colored object in the photo. It's absolutely huge, so it's hard to get a picture that you can even get the extent of how big this boiler is. In the boiler, the water is heated using a fuel source, likely natural gas, to produce steam. The larger boilers on campus can produce up to 45,000 pounds of steam every hour, while the smaller boiler can produce up to 18,000 pounds of steam every hour. Both of those produce a huge amount of steam every hour, as you can tell by how large these boilers are. So, the steam is what is pumped across campus and used to heat buildings. When the water quality in the boiler has reached its lowest acceptable limit, and that happens when water has been condensated so many times that it's almost getting old in a way to think of it. It's this water is then discharged in a process called blowdown, which you can see in the diagram here, to prevent scaling and control energy consumption as well. So, a little bit about the boiler fuel since we've been talking about the boiler. What does the heating plant use as a fuel for the boilers? It used to use coal, but in recent years, natural gas has become cheaper than coal, and it's thus become the predominant year round fuel source. Additionally, due to environmental concerns and restrictions, coal was expected to be phased out as a fuel by 2021, anyways, but its use was halted earlier due to a small coal burning boiler fire in the spring of 2020, which damaged the plant and made it unfeasible to use coal any longer. The plant also has a 20,000 gallon underground and a 25,000 gallon above ground oil tank that contains fuel oil. But due to its super high cost, which you can see in the middle column here, it's only burned in emergency situations and to test equipment in order to save money. Another kind of fun tidbit here, wood was experimentally used as a substitute to coal and natural gas several years ago as a more sustainable option. Wood is technically considered a renewable resource because you can grow a tree. It will take many years to grow that tree, but it's certainly not even close to the amount of time that it takes to replenish natural gas or oil reservoirs. Unfortunately, wood was not compatible with the machinery present at the plant. The wood pellets would only partially burn, which would leave hot embers in the collection bin, and this was troublesome because these hot embers sparked small fires, and obviously that presents a plant hazard. You don't want anything burning or blowing up in the plant. So wood pellets are not used at the plant today, but they have been tried in previous years. So we get to steam transfer then. Once the steam is produced in the boiler, it's transferred out of the heating plant through steam pipes at 50 pounds in the summer and 100 pounds in the winter. This steam is then transferred across campus through an underground network of pipes, taking about 3 seconds from leaving the plant to reach Johnson Hall. And in case any of you don't know, the central heating plant is the building located just south of Rodley Hall. It's the building with the big tower on top of it. So that's a very short amount of time for that steam to be funneled from the central heating plant all the way almost across all of campus to Johnson Hall. And the transfer of the steam is most clearly visible in the winter when long stretches of snow are melted on campus. These areas are above the steam lines. The areas where the snow is melted is above the steam lines, which are transferring hot steam and thus causing the above snow to melt. You can't be perfect with your insulation of the steam pipes, so obviously a little bit escapes and melts that snow. You've probably seen that before on campus, maybe walked through those paths because there's no snow there. And that's what that is. These pipes, the steam pipes, are accessed for maintenance and any sort of other issues through what are endearingly called the mushrooms, which you can see in this middle picture. They're scattered throughout campus. You've maybe sat on them before or seen them walking around. They do have a purpose. They're used to access the steam pipes. So, the actual steam usage. Once the steam travels through the underground network of pipes, it's transferred to and travels through campus building through the ducts. These ducts then warm water or provide heat through vents. If you've ever had a class where you've sat next to one of these vents, you can tell that it's a lot warmer than across the room, and that's because it's um, funneling steam through it, pushing steam through it, and that's how it heats the building. So then I've kind of touched on this before, but once again, reusing the condensate is important. When the steam cools and condenses in the pipe, it's called condensate. This condensate water has very little impurities and it's very hot, which makes it ideal for essentially just transferring it back into the system, back into the boiler feed water. Returning the condensate back to the boiler saves water, but more importantly, it saves fuel and thus money. If condensate is not returned to the boiler, then the boiler needs to have fresh water introduced, which needs to be preheated and pretreated, which burns fuel and chemicals. The bottom line is if you can return most of your condensate and keep it hot, you can save tons of money and energy. Thus, the pumps like those on the right catch condensate and funnel it back to the deaerator for treatment. Multiple of these condensate pumps in the plant act as backup in case one fails. So, another last little tidbit here, the central heating plant supplies steam to 18,395,483 cubic feet of building space on campus, as well as heated water. So that's a huge amount of area. And all of this is extremely important in keeping campus up and running as it supplies heat to campus as well as the hot water systems. Especially in our climate where it can be pretty cold in the winter, it's important to ensure that our buildings are heated so that we can continue class. The hot water to wash your hands or take a shower is coming from the central heating plant, as is the heat that is so vital in cold winter days. Because of this, the central heating plant is one of the most important operations on campus, yet it's often passed by students or not even noticed. All right, so that's the end of our virtual tour. If you have any additional questions, please reach out to the Office of Sustainability at that email address listed below, and we can get you in connection with any other resources, as well as any resources considering sustainability on campus. Thank you for watching.